Hello, my name's Tom Jordan and I'm a scientist at the British Antarctic Survey. The study that we're talking about is about Thwaites Glacier, which is a really massive glacier in West Antarctica. Today it's contributing directly to global sea level rise, and it has the potential in future to contribute up to 60 centimetres to global sea level rise. If you plot out the slope of all the various glaciers, Thwaites shows up as a bit of an outlier in that the glacier surface is much steeper than many of the other glaciers. It's been suggested from some modelling work that this is because the base of Thwaites Glacier is more sticky. But what in this study we've actually tried to do is understand why the base of Thwaites Glacier is more sticky. As we took the BAS Twin Otter survey aircraft and we flew it over the glacier with a set of sensors on board, we were able to build a picture of what the geology is underneath the glacier. It's flowing at 90 degrees to the geological texture. So it's flowing over, if you imagine you're flying over a rumble strip, it's flowing across the texture of the underlying geology. There's actually less sediment than we might have expected. And this is really important because the sediment is slippery and helps control how fast the glacier is going to flow into the ocean. So these findings are important because they will allow modellers to better understand the processes that are going on beneath the glacier and controlling the glacier flow, which means the models can be improved so the uncertainty about how fast Thwaites Glacier will retreat in future will be reduced.